Okay, welcome everyone back to the video. So on this video, we'll be learning about how to action move our servos. So in FTC, there's different types of motors, servos. So the most basic type is a servo. So a servo looks something like this. Okay, so without the top on, it's just like a mini gear here. With this, it rotates and it's a kind of like a smaller motor. So this can be used for arm purposes, hand purposes, and things like that. It's not strong enough to work as a DC motor, but it's strong enough and it's capable of lifting different things such as the arm or moving the claw back and forth for the power play where you're collecting cones. So here I'll show you how to code this exactly and how it's going to work. So let me share my screen real quick. So if you see here, if I go open up Android Studio, I go to downloads, I go to FTC remote controller, SRC, Java, and external. There's this whole list, but if you see closely, there's a concept scan servo. So if we click on concept scan servo, we come into a preset Java code that tells the servo what to do. So let's start off with the beginning. Let's take it step by step. Here, that's package. So this is the package of the first Inspire. So this is where the SDK is built in. This is the package. It's importing all of these Qualcomm classes. The op mode, it scans. So if you see here, this shows what exactly it's like an overview of the code. So this almost gets a single servo back and forward until its stop is pressed. So for example, if I click the button B on my controller, it'll turn one way. And if I click X, it'll turn the opposite way. And I'll keep going like that until stop is pressed. So if we see here, let's go to the increment. So these are where all the variables are being defined. So static finite double increment equals 0.001, which is the amount that each cycle is slewing the servo. The cycle is 50, the period of each cycle. The max position is 1.0, so the position can be between 0.0 and 1.0. So it will always rotate between 1 and 0. So here we define all the class members. So the servo, double position, max position, minus minimum position. So you start at the halfway position. So when I click initialize on my robot controller, it'll always start at the halfway position. So I'll either go to 1 or 2. So that's why it says max position, so the max position, which is 1, minus the minimum position, which is 0. So 1 minus 0 equals 1, divided by 2 equals 0.5. So I'll start at the halfway position. So the public void, this is where the op mode is actually starting. So this is where the actual code starts, where the actual code is moving. You connect to servo, assume robot left hand, and this is where it defines from the hardware map. It defines the servo as a left hand. So what you'd have to do at this stage at this point in the process is you'd have to configure your driver hub. So in this case, if you're on an online virtual simulator, then this wouldn't be the case. But you could do this on a driver hub. So let's see here.